Hi everyone, in this video I'm going to introduce you to the new value operator that has been released in the last tyFlow version. So if we open a tyFlow editor, we can see that we have now access to a very new operator called value. And as you can see, it comes in a different color event, and the reason for that is that it can't be stacked with the other operators. We can't put them together. So what are we supposed to do with it? Well, basically the purpose of this operator is to control the parameters that you can find in other operators. So for example, let's take this speed operator, and we can see that some spinners have now this little icon, this little diamond just next to them. Every time you see this icon, it means that you can use a value operator to control it. So the first thing you need to do is to click on it, and it will expose the value. And now we have access to a new input on which you can connect a value operator. And you can also, of course, create it by drag and drop it, the input. So now let's take a quick look at what we can do with this value operator. So as you can see, we have a lot of options and we're going to explore them in a moment, but right now let's keep it simple. The most basic thing you can do here is to override a value. As you can see, for now the magnitude is set to 1 because it took the magnitude from the spinners of the operator. And here we can see that it completely overrides the value. And you can see that the spinner is now grayed out. We can't really use it because it's being controlled by the new value operator. So we have a lot of options that, again, we are going to discuss it in a moment, but the most interesting part, in my opinion, is that we can now control different spinners from the same value. So if I duplicate this flow and I want the speed to remain the same, I can use the same value for both of them. So again, I have to expose the magnitude here, and I can simply connect this value operator to the other speed operator. And now we can see that we have the same value used for both of them. And you can do it with as many operators as you want. It doesn't have to be the same kind of operator. So for example, I can add a rotation operator here and control the X rotation using the same value. Right? Sometimes you also want to instantiate two operators because you want them to be identical, and you can do it with Alt-Shift pressed while you drag and drop an operator. And now these two are instances, and you can see that I still have this value operator plugged into the first one and not on the second one, which means that I can actually override a value from an operator that is also an instance. A better way of understanding this is to work on the seed here. Sometimes you want two operators to be identical except for the seed. So let's expose this operator seed, and now let's apply some variation. And we can see that we still have the same result because it's the exact same operator, but here I'm going to change the seed, for example, another value, and that's very handy in many situations. We still control these operators with a unique value here because they are instances, but we can give each one a different look by overriding the seed value here. So let's keep our example with the seed. Let's remove this one. All right, I set the variation to 0% so you can really understand what I'm doing. Here I have value type in absolute mode. If I switch to range, I have access to a minimum value and a maximum value. Each particle is getting a random value between the minimum and the maximum that you define here. And of course you can play with the curve just below to customize the randomness distribution. So you can, for example, contrast the distribution. You have already presets. If you right click on it, The most important thing to understand with this new way of working is that a lot of tasks that used to require a script operator can now be easily achieved with the values operators. Let's take an example. I have this script. So it's a script that allows us to multiply the velocity by a text map. And here basically I'm using this noise map. Alright. And I'm going to show you now how to replace it with the new values operator. Alright, so let's go back here. Let's recreate it from scratch. Let's add a burst operator. Let's spawn all the particles at frame 0. Let's put our particles on the sphere. And let's use a surface force. Alright. And in the normals menu, let's just add a small force, and we can set the timing to event entry. We can add a speed operator below the surface force and set the magnitude to inherit previous and the direction to inherit previous also. So it doesn't do anything right now, but we can still play with the multiplier here, and that's what we're gonna do. So expose the multiplier, assign it a value operator. So by default is taking the value that was on the multiplier, so nothing is happening. But if we switch the mode to Texmap and open the material editor, let's create a new noise, right? And then we just have to drag and drop the noise to the Texmap slot. We can see that it's affecting a bit the simulation, and since we are not using any objects UVs, we need to switch the source mode to world, and then it's gonna work better. Then just find the right amount. So as you can see, it's very easy to use, and of course after that, if you want to increase or decrease the strength, you can use the multiplier here. And the benefits of using this method instead of the script is that, first of all, it's easier to use, it's faster, and also it's going to be less time consuming for the simulation, because by default the script is not multi-threaded. You have to make some adjustments and it can be a pain to do it. So I would suggest you for a simple task like this to go through value operators, because it's going to be much more fluid for you. Now we can switch to another example. Let's create a simple flow here and remove everything instead of the position icon. Can spawn again the particles at frame 0. And we can use a spread. As you can see, when we play with the Z value, all the particles are being affected on the same level, right? But if we expose again this specific value to a value operator and again switch the type to Texmap, we can here look for a wave Texmap. We can adjust a bit the parameters of the Texmap, and in order to see the effects over the time, we need to set the timing mode of the spread operator to continuous, right? So we can see something happening, and now we need to animate the wave, because right now it's kinda static. So in order to do that, we can play with the phase here. That's the settings that will allow us to get an accurate wave animation. So what we can do is to right click on the value and use a nice feature that comes with tyFlow that allows us to set easily our keyframes, and we need to choose something kinda smooth. And we can see that over the time the overall level is rising, and that's clearly not something that we are looking for. So to prevent that, we can use another operator that has been also introduced with the value operator, and it's called restore. So if we put it above the spread, we can see that each frame it will restore the properties that are being checked here to their default values. So it will restore the values of the particles when they first enter the event. And it's very handy in this situation because we don't accumulate the changes over the time. So we have something that is starting to look good. We can eventually multiply the value here. After that, you can still play with the map settings. So using Texmap is very handy in many situations, and I can only suggest you to play with the other text maps that you can find in by default in 3dsMax, such as a dent map or even the checker. I know also that the default noise can be sometimes a bit frustrating because it's limited. Fortunately, if you go to the OSL, you can see that we have many more noises that you can play with. So you can actually play with all these maps, but if you are interested of making very specific oriented kind of animation, you might want to take a look at the expression mode. So let's reset the multiplier here, and we have here a little help that will provide you some explanations. So it's not like the script operator, but it allows you to create simple expressions to drive your particles animation. So you can find the documentation related to this expression language. And sometimes an expression can be a bit larger than this text box, so we can expand it using this little button here. So here we are using a cosinus basically to create a wavy animation. And you can play with the values here to get something more suitable for you. And again, you can still play with the multiplier after. And you can, of course, have access to particles properties. So let's remove this one and create a new one. And in the value here, we can right-click and assign a controller. And the one we are looking for here is called waveform float. And this can be really handy in many situations because it's not affecting the particles according to where they are in the world, but they are all being affected the same way. So if you need an animation where all your particles are going back and forth, it's actually a good way to achieve it. And you have some very nice feature. So actually you can already do it on regular spinners. You don't really need a value operator to do that, but I thought it was a practical way to show you some different kind of stuff. Another thing that I used to do with the script operator was something called a value over life. And what it does basically is that it assigns a value to particles, and this value is going to decrease over the time. And again, you can download it on my website. So it's here, value over life. And it can be very useful, for example, with smoke simulation, when you have particles that needs to emit smokes for a certain amount of time, and then the smokes fade off. And as you can see, I implemented different kind of parameters such as variation, clumping, even a seed. So again, it's working, but it's not multi-threaded. So I'm going to show you a very simple way to reproduce this with the value operators. So I'm going to create a simple icon flow. I'm going to use an icon that I already have in my scene. And again, I'm going to create just a bunch of particles this time. No speed, no shape, no mesh, we don't need it. And just make sure to see our particles in the viewport. What we can do is here use a custom properties operator. And the first thing I want to do is to set its timing to continuous, because the value is going to decrease over time, so it needs to be working continuously. And I'm going to create a channel, let's name it value over life, and we can already display it in the viewport. And our value is properly created, as you can see, and we can now expose this spinner to a value operator. So here we are looking to create an effect that is based on our particle age. And if we take a look at the different kind of values that we can use, we can see that we have one called property. And by default, the exposed properties is a position X. So that's what we see here. Each particle is getting the X position as a value, but we are not going to use this one. We are going to use the age. So you are free to use the event age or the particle age. I'm going to use the event age. In this case, it doesn't really matter because we only have one event, right? And we can already see that the particles are getting their particle age as a value. So it's working. Now what we want is something a bit different. We don't want the value to increase, we want the value to decrease and to start from a certain value, right? So how can we do this? Well, it's a nice occasion to take a look at what we have here. So we have something called adjust values that offer us different kind of possibilities. The one that we are actually looking for and that's gonna help us in our case is normalize. So you can activate it. So basically what it does is that it takes the value that you created above and it simply normalizes it between the minimum and the maximum that you can set here. Normalize it means that it will give a value between 0 and 1. So when our particles are at frame 0, the value is 0, and when our particles are frame 100, because that's what we set here, the value is going to be 1, right? So if we reduce it, we can see that it goes even above 1, because now the maximum is 80. And we can see that when we play along the timeline, we can see that the value is going to increase. So that's already nice, but not exactly what we are looking for. The problem here is that the value is starting from 0 and it's increasing over time. We want the opposite. And to do that, we can use the invert option here. And we can see that the value is going to start at 1 and then going to 0 and even below. And that's what we want. So if you want your value to stay between 0 and 1, we can use this other option that's called clump, and we can simply set it between 0 and 1. And now, even after the maximum age, the particle value will no longer get below 0. And that's exactly what we are looking for. So the effect is already looking great, but we can even make it better. So what I implemented in my script previously was the ability to get some randomness. And we don't have it here, right? All the particles are getting the exact same animation. So how can we introduce some variation? Well, you might have noticed that we have this variation parameter in the value block, right? So I can already play with that, and that's great. So the default mode is in %, which means that the variation is going to be a number between 0 and the actual value, right? And the other mode is a variation based on more or less, right? So it can be even above the actual value. It can be something like that. So you can play with that and it's going to work, but I want to show you another method. So let's set this variation to 0. And you might also have noticed that some of the settings here have also this little icon that we saw previously. And it simply means that we can connect values operator to other values operator, which can be very, very interesting, and it can help us to create some complex setups. So what we want here is to add a maximum life randomness. So we can expose this maximum value and connect a value operator to it. So as you can see, it's again taking the values that were already set up here, and what we can simply do here is introduce the variation in this area. So now we have a nice variation. So that's great. We can use this value, this custom float, for example, in FumeFX to control the smoke emission, but you can also use it for other purpose. For example, if your particle is supposed to emit less smoke, it might also be smart to use this value to control the scale. So that's what we're gonna do here. So let's add a scale and set its mode to absolute. And you can already set its timing to continuous. We can now expose the scale values. And in order to see the actual scale in the viewport, we can switch the mode to sprite. And if I connect my value operator to the scale, we can see that the scale is still very small because the value is contained in a range between 0 and 1. So it's not going to be enough. What we want here is to multiply this value by, let's say, 1000. If I'm using the multiplier here, it kinda works. I mean, we see the particles bigger in the viewport, but it's also affecting our value between 0 and 1, and we don't want that. We want to keep our value between 0 and 1 and to somehow have bigger particles. So let's reset the multiplier. And instead of that, what we can do is to stack another value operator in our list. And we can already connect it to the scale. So by default, it doesn't change anything. Well, we have something here above that we haven't really talked about. In the input block, we can see that we have an operation list, and by default it's going to multiply. It means that it will take any value that's above him and multiply it by this value. We can also do different operations, but what we are looking for here is the multiply mode. And as you can see in the way it's labeled here, we can see that it's taking the current value from the top and multiply it by this number here. So what we can do here, for example, is to multiply it by a bigger number, let's say 10 or even 20. And now everything is working together, because when the first value reaches 0, the scale will also be set to 0. So that's working great, and if I change this value, you can see that it's also affecting the scale. So everything works together. I'm going to show you another example of why the values operator can be used in many situations. Here I have a wobble affecting all these particles, and the problem that we had previously is that the scale value here was the exact same for every particle, which could be problematic, because if you have particles of different sizes, you want the animation to be a bit different, to be more accurate. So if we simply use our particle scale to control it using a value operator, then we have something way more accurate. The wobble targets are now in the top of the particles. And now each particle is behaving according to their size. So this example is mostly to show you that it doesn't have to be very complex. Sometimes it can be a simple adjustment and it makes a whole difference. So a new thing that we can do now is to control also the vertex color based on distinct values. And as you can see, we can use a values operator to control them. So that's what we're gonna do here. What I want basically is to have a gradient from the center of this icon to the border, right? So what we can do is to use another mode that we haven't really talked about, which is the surface mode. So surface mode can be used with geometries, but here, since it's a helper, we are going to use the pivot distance. So we need to know a few things. So we know that each channel of color is going from 0 to 255. That's a basic 8-bit of color assignment. And right now, we don't really know what is the value of the distance. So what we can do here is to use a custom properties just to display the distance value in the viewport. We need to plug our value operator to it, and we can see that the maximum value seems to be around 250. Why is that? Is because our icon has a diameter of 500 and the radius is half the diameter, so it's gonna be 250. And that's what we see here on our particles. So by chance, our particles are almost going from 0 to 255. And by default, the display operator is displaying this color, but we can display a map channel. Let's decide already the channel we want to see, the channel 1. And in our vertex color, we can apply this value. I'm going to disable our display data, and we can see that we already have something nice. So I'm going to remove these two operators. We don't need them anymore. And I'm going to show you how to make some adjustments if this icon changes. So let's take a crazy value like 5000, and now we don't have anymore the gradient because the values are completely different. So what we can do to fix it is to use another adjustment option that we have here, and it's called retarget. So a retarget is basically going to move a value from a range to another range. That's what we can do in the script operator with a remap function for those who know it, or if you are used to Houdini, it's the same function as a fit. In order to make it work, we need to know the minimum and the maximum value. So the minimum, it's always 0 because it's the center of the icon. But the maximum, like we said previously, it's half the diameter. It's what we call the radius. So half this value is, it's 2500. The minimum is 0 and the maximum 2500. And we want this range to be scaled down to a range that goes from 0 to 255, which is the maximum value of red, green and blue. So now it's working fine. And the fun part here is that you have the ability to play with a curve to maybe contrast it. So you can do your own test. So let's reset this one. So it's working fine, but if we ever change this icon diameter, we have to readjust after that the values in the retarget. And that's a bit annoying for me. So what we can do here is to link our maximum value here to another value operator that will always have a correct value. And how can we do that? Well, there is something in 3dsMax called wire parameters, which allows you, it's a bit the same as linking parameters in Houdini, and it's working fine with tyFlow. So we can just right click and select in the menu that appears, show wire in parameter wire dialog. So we have this window that appears. The left window here is showing us the value that we want to link from our value operator. And we can now select our icon and just update the right window. It will show us our currently selected object. And if we look through its parameter, we can see that we have something here that is controlling this value. What you can do is make this value be the master of our value operator. And in order to do that, you can use this one-way connection, right? And to connect it simply. And now if we go back to tyFlow, we can see that our value here is the same as the icon. And you can't change it, it's locked. It's only being controlled by the icon. So it looks good, but the only problem is that, like we said previously, this value needs to be divided by 2 because it's not the radius, right? So what we can do is to divide it by 50%. Or you can leave it at 100 and use another value. Instead of multiply it here, divide it by 2. And it's working fine. Now that we've covered most of the features of the value operator, let's quickly go over the remaining aspects. First, you might have noticed that the value operator includes 2 familiar rollouts, the filter rollout and the keyframe rollout. The filter rollout allows you to include or exclude specific particles. Essentially, any action you perform within this operator will only apply to the particles approved by this filter. The keyframe rollout is also very useful because it lets you animate by hand using keyframes and then decide how to play the animation. It comes with several handy features such as randomization and offset. We've already seen most of the value types, but let's briefly cover the rest. So the first one is current frame. So it simply means that the value will match the slider position in the timeline. And you can actually do the same with the expression mode by simply using the t variable. Values in percent is the mode you should use with the spinners that takes percent, such as variation, multipliers, or acceleration, for example. Value world space is similar to the regular value, but it will display the units. Here, for example, we can see that we are in centimeters. It doesn't change anything else. It's also worth noting that every value type can be adjusted using the relative to property option. We haven't discussed the make absolute option yet. It's a very simple one. It simply converts negative values into positive values. If you stack multiple value operators and you want to quickly see the result with or without some of them, it can be inconvenient because you have to relink them every time. And that's why we can use the event output. As you can see, you can link it to a spinner to see the result of the stack. And you can play with the operators within the events without having to relink them every time. And it will simply output the result of the stack to the spinner. We haven't really talked about the input options here. You can find more information here, but you just have to know that if you have a stack of values operator, the default value of the whole stack will be derived by the first one in the stack. In my opinion, it's not the most important thing to know. It can be useful sometimes to play with these options, but I think that most of the time you will use the default one, which is the pblock default. And basically you might sometimes want to use a from source spinner mode. And what it does is that it will let you use the original spinner it's been connected to. So any operations that you perform here will be applied to the spinner itself. As you can see, it's not grayed out anymore. To conclude, I would like to make a point on what I believe is the most underrated feature of the value operator, which is the ability to combine it with the script operator. Previously, the getFloat function allowed us to expose a value outside of the script operator. But now, these float values can also be connected to value operators. Make sure to use the extended function, which takes now the time and the simulation index as arguments. Here, for example, I'm adding a simple variation to the script that saves me a lot of time. Alright, thanks for watching this tutorial. I hope you found it helpful. You can download the file in the description, and don't hesitate to ask questions. I will try to answer in the comments. Bye bye.